Okay, very good morning, everyone. First of all, I would like to welcome you all for our GATE coaching class. Today, we'll be having two sessions. First session will be on morning, that is programming and data structure. And second session will be handled afternoon, algorithms. So, hope you will find it useful for your GATE preparation, which will be useful for your higher studies and also for getting your central government jobs. So, make it useful. Now, I take a pleasure on welcoming our expert for today's session for the subject Programming and Data Structure, which will be handled by Dr.B. Dhiyanesh sir, Associate Professor from Department of Computer Science and Engineering from our own institution. I think so. His tips for your coaching will be helpful for you for solving the data structure paper. So once again, I welcome you all and welcome you, sir, for today's session. Now I'm handing over the session to you, sir.
Thank you, ma'am. Don't want any that brief explanations and all. We are in the same institutions, so no need of brief explanations. So, good morning, students. Is my voice is audible, ma'am? Is my
Yes,
voice
sir.
is audible? Yeah.
Yes, sir. Audible, sir.
So, before going to the grade preparation, so you need to start from the second year itself because it is very complicated uh, for the gate. The reason behind is uh, every year around 10 lakh students of from our India they are applying for the gate, and only from that only few of managed to clear the exam with a good score. So you can have the clear view of this competition. So it is very tough, and simply preparing without any strategy will make it is very difficult to land you in IICs or IITs, or you're doing a ME with a scholarship or in an universities or like that. So it is preparing is very difficult without any strategy. So if you are in second year, it is a good time to prepare yourself to get a good marks in a gate, and all those things. It is simply like an aptitude only. They are just twisting you because. This is the first time I'm going to handle this gate coaching. I'm going to take up this coaching and all. And I look up some questions in the previous year questions, and I show the examples, all those things in your presentation. All those questions are giving some twist only, but question is very simple. With the one line, if a question is suppose 3 or 4 lines means with the one line you can able to find out the answer. So you need to understand the question very clearly, and what is the actual question. That is what you need to know. So in the out of this three line, only some 5 to 6 words are only the question. The remaining are the confusion. They're giving some confusion manner what is happening behind that. So clearly understand the question. That 6 to 7 words. After that, find out the respective answers. If you do this, means you can able to clear the all the questions and you can able to score the good marks. And recent survey, what they're saying is around some 2 lakh students they are appearing for the gate in our Tamil Nadu, and out of that the gate result very less. Failure highest in Tamil Nadu also. Very less amount of students are um, getting a score in a gate. So our students are not at all aware about the gate importance and the scholarship. From that, you can able to get the scholarship for entire two years of higher studies. That and all you can able to get it easily. So without aware this, the students are simply appearing for the gate. But according to the literacy rate, we are in a good position in our all over in India. I think we are in eighth rank in literacy rate, around some 83% or 84 percentage. So literacy rate is very good, but we don't know what are the score outside of the score, who are all giving a scholarship. This and all the thing you people don't know. So the Tamil Nadu registered the lowest success rate due to the limited exposure of Tamil Nadu candidates. This is a major reason and caused by their for they can't able to compete the examination. Simply, I am applying for the gate, and they are going to paying the fees and attending the exam, and they can't able to clear. So this is not a good way. So if you are in the second year, it is well and good. You can able to prepare. This is a good time for you, and you can able to prepare and you can able to crack the gate all the questions and all. So you need to spend at least some 3 to 4 hours per week, from starting from the second year. If you are in the third year or final year, you need to give more concentration for this because you need to give at least some 8 to 10 hours. Weekly, you need to give some 8 to 10 hours. One second. So you need to prepare at least some 8 to 10 hours every day, so you can able to crack easily all those things. So this is a major thing I need to say. Better at least per day you need to spend 8 hours to 10 hours. So only you can able to crack this. So first we are going to prepare the gate and all. Let we go directly for the data structures. So your syllabus for your data structure, programming in C, recursion, arrays, stack, queue, linked list, tree, binary search tree, binary heap, graph. These and all the syllabus for your data structure. Uh, so what we are going to plan is, first we are going to look up for the arrays and followed by stack and queue and trees, binary search tree, binary heap and graph. Finally, we'll come back to the linked list, programming in C and recursion. So why I'm going for this order is because this order is very simple. Array, stack, queue, and all very simple. We can able to crack very easily. Trees, binary search trees, and all very simple because the problem statements are very less, and a lot of problems we can able to solve easily. But if you're coming for the programming in C, recursions and linked list, most of the times they're giving what I seen in the last 2 days. All the gate questions are everything is a programs, mostly all programs. In the linked list, mostly everything is a program. So I think some 8 to 10 questions I seen out of those 10 questions. Only two or three are some problematic. So problem not a problematic. We can able to that is we can able to solve very easily when compared to the programs. So first we try to complete this array stack queue, trees, binary search trees, heaps, and all. After that, we'll come back to the programming, C, recursions, and linked list. So, you know about the array. So, array is a kind of a data structure. So that can store the fixed size sequential collection of element of same type. So here the same type denotes the data type. So what is the reason behind going for the array years? If you want, if we are collecting some details of the students, marks. For example, a student roll number is uh, 45. I'm going to get this 45 student details of marks, mark 1, mark 2, mark 3, like that, or the name of the subjects. If you are in third year, if you are in second year, let I say DBST, then M3, then data structure, then DBMS, then computer architecture, like that. We have some five, six subjects marks we have. So instead of using six variables, we are combining together all the six variable into a single variable. So that is the array. So mark of m of 6. Okay, m of 6. So all this m of 6 are associated with a common data type, integer or a character or the float or double or long. So like that, it is associated with the same type of data type. This is the main advantage of array. And next one is everything is a fixed size of sequential collection of element. Fixed size sequential collection of the element. This is the next important point. So here the fixed size sequential collection of element is we have all the elements are belong to the data type integer, means it is the same memory allocation is given for all the things starting from m of 0 to m of 6, and it is a sequential one. So sequential one is one after another. So if we can able to get the m of 0 only, we can able to go for m of 1 and m of 2. Like that only we can able to get the values. A sequential one. So array is used to store the collection of data, but it is often more useful to think of an array as a collection of variables of the same type. So collection of variables of the same type. So instead of declaring the individual variables such as num0, num1, and num99, up to num99, you can declare a one array variable such as the number and use a number of 0, number of 1, and number of 99 to represent the individual variables. So instead of this number 0, number 1, number 2, number 3, up to number 9, instead of declaring an individual variable, you can able to declare the number of 99 or number of 100 you can able to declare. So from this, we can able to get the variables, individual variables. How to get the individual variable is, so number of 0. This is the individual variable, number of 0, and number of 1, number of 2. Like that, we can able to get the individual value also. So with the help of the index, we can able to have the direct access to the each and every element. So the specific element, if you look at the next one, the specific element in array is accessed by an index. So we can able to direct access to each and every element with the help of the index. So here the index is denoted as a 0, 1, 2, 3, 4, 5, up to 99. It is a sequential one. So the lowest address correspond to the first element and highest address correspond to the last element. So here the lowest address, instead of that we can able to say the lowest index value is correspond to the first element and the highest index value correspond to the last element. So here the lowest element is 0. Index value is 0. The highest address is, that is highest index value is n minus 1. Why we are saying n minus 1 is, if 100 is, we are starting from 0 to 99. Your size is 100, so n minus 1. N minus 1 in 100 minus 1, that is 99. So 0 to 99, your value. So starting from 0 and 99, so total value is 100 because we are started from 0. So this is one example. So index is start from 0 and end with 5 because the size of the character str is 6. The size of the character str is 6. So starting index value is 0 and ending is 6. So that is 5 minus, sorry, 6 minus 1. The size minus 1. That is 5. HELLO. So each and every value, this is string is going to place in string of 0 is placed with H and string of 1 is placed with 1 and 1 second. And L is placed in index 2 and another L is placed in index 3 and another O is placed in index 4 and last is null. This is for especially for the string. So in string what it happens is it takes some size plus 1 memory for the strings. So this is especially for the string only. And in address also in the sequential manner. So address is a sequential manner. The size of the character is 1, so it is goes by the address plus 1 in incremental manner. So the starting address of str0 is 1000 means it will go according to size plus 1. So that is address plus 1. Why it is 1 is the size of the character is 1. Instead of that, if you are giving integer means, it will go with the size is 2 means. So with our first address is 1000, second address is 1002, third address is 1004. Likewise, it will go. So this is a sequential collection of the element at the same time. One is with respect to your index value, another with respect to your address. So both have the sequential thing start from 0 to 5 as well as your address also goes like a sequential manner. So this is one advantage of array. Next, how to declare the array. So it is like a normal variable declaration. So normal variable declaration, how you declare this data type. Uh, So like a normal variable, you can able to declare the array also. That is a data type followed by a array, a variable name. Variable name is v1, like that you can able to give. So it is a normal variable declaration. So the compiler able to understand, or a normal human being able to understand with differentiate between a normal variable and array with help of the square bracket. If it is the variable is have some square bracket and with have the size means, then it is array variable, and without any square bracket, then it is a normal variable declaration. A compiler, a normal human being able to understand by this terms. So the data type followed by the array name and followed by a size. So the example is double balance 10. And here there is some constraints of naming the variables. Not only for the naming the variables, we have a lot of constraints for naming the variables, function, structure name, union names, and all. So it should be start with the alphanumeric. So first you need to start from the alphabet. So that is example is V and followed by a numeric 1, 2, 3, and all. So you should not like 1V or 2V like that. So it is wrong. So it should be start with the alphanumeric. This is the first one. Next one is there should not be any space between. If I consider this is an example array name. So I'm going to write array name. Then what happens? It throws some error. So the compiler won't takes the space between here. So we can able to give a space, but instead of that, we need to use only a special symbol for that. The special symbol is underscore. So only the underscore we can able to use instead of that space. Okay. So the space is voided. So for that, we can able to use the underscore instead of that space. Second one is we can't able to use a reserved keywords. So reserved keywords is a int, character, float, then void, then if, else, for, while, this and all the reserved keywords. So this reserved keywords we can't able to use for naming the any variables or structures or union or function names, etc. So compiler won't accept that one. So we can able to change the reserved keyword names. After that, we can able to use. So for example, I'm saying while. While is a one reserved keyword. Okay. So instead of that, we can able to use one here or two here. So the name of this variable is changed. While one. So while is a keyword. After that, it is one. So it is not a keyword. So we can able to use a reserved keyword also. So instead of that, WHILE also we can able to use. So the ASCII value for the small w and ASCII value for the capital W is totally different. So the compiler only check with the ASCII value of this small w HILE. What is the ASCII value for all those is 5 characters. So if 5 characters match with the reserved keyword, it won't accept. But here the ASCII value for capital W is totally different. So now the compiler will understand. So it is not a reserved keyword. So likewise, we can able to rename the reserved keyword and we can able to use. So that is the one thing. But preferably don't use the reserved keywords. If it is some situations you are come across while using the reserved keywords means just rename the reserved keywords and use that one. So that is a well and good. So this is an example for declaring the array. So data type, I'm using a double, and array name is a balance, and the array size is 10. Now it is a array declaration, declaring a array. So if I same double and balance, if suppose I'm given means what happens? This is a normal variable declaration. This is a normal variable declaration. Okay, because it is not enclosed with any size and open and closed square brackets. not enclosed with any open and close square bracket. So it is a normal variable declaration. This is how the compiler will able to differentiate the normal and array variables. Next, how to initializing the array. So we can able to initialize in two manners. One is while writing a program, at the time we can able to initialize our values. So it is a one example. So double balance 5 and 1000, 2.0, 3.04, 7.0, 50.0. This is a value for this double of 5. Sorry, balance of 5. So this is enclosed with the square bracket. This value are enclosed with the square bracket, not by the parenthesis, not by this parenthesis. These values are enclosed with the square bracket. Sorry, not a square bracket, flower bracket. I wrongly said flower bracket braces. Okay. So what is the meaning for this value? 1000, 2.0, 3.4, 7.0, 50.0 means it create an array and it holds 5 values starting from 0, 1, 2, 3, and n minus 1. So 5 minus 1 is 4. And in balance, so this name of this array is balance of 5. Balance of 5 or the balance. Okay, this name of this array is balance of 5. Okay, so in balance of 0, it stores the value 1000. And balance of 1, it stores a 2.0. And balance of 2, it stores 3.4. And balance of 3, it stores 7.0. And balance of 4, it stores 50.0. Likewise, it will store. What is the major problem in this type of initializing array is you can't able to change. You can't able to change it. So if the value is fixed, if the value is fixed means you can able to declare or you can able to initialize. So we can able to say some examples. The leap years are so 2000, 2004, 2008, to the 2012. This and all the leap years. This is a fixed one. We can't able to change it. At the time we can able to initialize with the array or the days Monday, Tuesday, Wednesday, Thursday, or the month January, February, March, April. This and all we can't able to change it. It's a fixed one. 12 months and 7 days. This and all the fixed one. So at the time only we can able to initialize the array. But if you're going for running a program, compiling a program and running the program, what happens? You can't able to change the value of the array. This is a fixed one. So before initializing the array, think of that and do it. That is the best one. Next, accessing the array elements. So accessing, we can able to access the array elements also. So in the two ways of we can able to accessing the array element, this is the first one. So the size of the array is about 10. So balance of 10. Already we seen this example, balance of 10. Okay, balance of 10. Now I said we can able to access each and every element individually in the array. So I am accessing the element balance of 9. Suppose this balance of 9 value is some 500. Okay, 500.0 or 500.12. Let me have this thing. So instead of taking all the values one by one, we can able to access the individual value because it is a the array is a individual variable also. We can able to assume as an individual variable also. Already we seen this. So it is a group of elements placed in a single name, as well as we can able to access the individual element from the array. So each and every index value is treated as a individual variables. So this is a one way. So balance of 9. This balance of 9 I'm going to save in the salary. So you need to before declaring like this manner, you need to know what is the data type of this balance. So the data type of this balance is double. The same data type we need to use here. The same data type we need to use here. This is a important thing, because if you use some other names, some other data type names means it won't give the correct values. It won't give the correct value for that. So if suppose you're giving a string, okay. So instead of that, if you're giving int means it is the type difference are coming. So keep concentrate for this type of declaration. Or else you can able to give like this also. If you want to print any value from the array means, you can able to print like this also. So print of percentage, the control string for double S, LF, that is a control string for um, double. For long double is capital LF, then LF element is just I'm printing element is, then balance of 9. Balance of 9. Okay, you can able to give this type also. So here you don't cause any problems. What is the balance of 9? That will print here with the help of the control string. This will print. Okay, it won't give any errors and all. So here, what is the problem is we need to understand what is the data type we used in array balance, and the same data type we need to use to store that particular value, that is balance of 9. We need to use the same data type to store in the salary. So this is a thing you need to concentrate. But here, this type of accessing the array elements, we don't want to concentrate anything here. Next, types of array. There is only two types of array. One is one-dimensional array. Next one is multi-dimensional array. So one-dimensional array is an example is a single square bracket. That's it. So on multi-dimensional array, we have multiple square brackets, multiple array index. So this is a two-dimensional array. This is a three-dimensional array. This is a four. Next one is four. Likewise, this will grow. So according to the multi-dimensional array, this will go as per the user needs. So single dimensional array is enclosed with of only one open and closed square brackets. So that is a thing for the single dimensional array. So according to a multi-dimensional array, if you do is we need to use a two square brackets, that is open and closed square brackets. This and all the types of array. Next one is what are the advantage and disadvantage of this arrays? Fast random access of items or elements. So with help of the index value, we can able to access very faster. If we know the index value, we can able to access very faster and more efficient, and less memory is needed other than need to store the content. Next, and this is a mm, major disadvantage of array. What is the thing is, suppose I'm giving the array sizes 5. Array sizes 5. I'm having some elements. Consider the elements are 2, 3, 4. Only 3 elements I inserted. So the total size of the array is 5. But I use only 3 elements. So remaining two spaces are free. So we can't able to reuse these spaces. That is a one problem. Second problem is, if suppose I'm going to delete this element 3. So what happens is, array is a sequential representation. So every time I need to shift this. Every time I need to shift this. I need to shift this 4 to index 1. So if the size is very less, then it is well and good. Time taken to shifting process and all very less. But if the size of the array is 1 lakh, or the size of the array is 2 lakh, I'm deleting the element. If the size of the array is 1 lakh, means I'm going to delete the element in 7,500, 75,500 and 75,463. Okay, or 15,463. So what happens? I need to shift all the elements from one place to another place. I need to decrement this and I need to shift the elements. This is a major problem. So the slow insertion deletion of the elements. And next one is the size is fixed to one. The static allocation. The static is we are fixing the size. So we can't be able to change the size at any time. So that is a major problem. If you're using the array, you need to know the size exactly. So if you're filling any online form, sometimes it won't accept more than the characters. What is the problem is they fix the size of the names or anything, they will fix it. If you're giving your number, mobile number, they fix the size. The size is 10. So likewise, they will do it. If we can't able to say we can able simply we can able to say the size of the phone number. It is about I think 10 numbers, but you can't able to say the size of the name. It will vary. One person name is suppose a character length is about 10 character. Another person name character size is about 25 character. We can't able to predict that. So that is a major problem in array. The size is fixed one. So with this some general introduction about the array, we'd actually go for some examples. So here I'm having some two examples. What I get it from the gate. So the two matrix M1 and M2 are stored in the array A and B respectively. Each array can store either in the row major or column major order in the contiguous memory allocations. The time complexity of algorithm to compute M1 and M2 will be. So your question is only we have a lot of paragraph here about 3 lines or 4 lines here. Your question is very simple. First you need to understand. So there are two matrices M1 and M2. That's it. Then your question is this is the only question you need to understand. This is a this is your question. Each array can store either in row or column major order in the contiguous memory allocations. This is a question. And after that, what is the time complexity? So they're asking a time complexity. So you need to understand this a particular statement only. If you understand the statement, then you can able to pick anyone from the four answers. So best if A is a row major and B is a column major order. So they said either in row or column. Next. So first is not correct. Best if both are row major order. So that is not correct. Best if both are in column major order. That is not correct. So it is depend upon the independent of the storage scheme. So that is your answer. Independent of the storage scheme. So this is your answer. Next, a program P reads 500 integers. So it reads 500 integers in the range 0 to 100. So this is your logic. It will read 500 integers. They will confuse you. 500 integers, they will read it. But what is the range? So with the range, you can able to understand what is the range. The range is 0 to 100 only. So I can able to store the value only from this integer 1 to 100 only. I can't go behind this. Representing the score of 500 students. It then prints the frequency of each score above 500. What would be the best way for P to store the frequencies? So what is the size of the array here? 100. So 0 to 100. Okay. So I can able to store the data only 0 to 100 only. But they are giving 500 integers. That is not our problem. So after that, it throws either the size of the array is full. That is not our problem. But they asking a question. This is the first thing you need to notify. Next one is I need to print the frequency of each score above 550. So above 50, that is greater than 50. So greater than 50 is starting from 51 to 100. The count is about 50 only. So greater than 50. It is not they given greater than or equal to, they given only greater than 50. So we have four answers. The array of 50 numbers, then array of 100 numbers, array of 500 numbers, and dynamically allocated the array of 550 numbers. The size of the array is 100, and they are asking to print who are scored greater than 50. So greater than 50 is starting from 51 to 100, not greater than or equal to also, greater than 50 only. So from 51 to 100. So from 51 to 100, can able to say it is only 50 records. So the answer is 50, not 100, 500, or it is allocated the array of 550 numbers. Only 50 numbers we have. So they will confuse like this. So don't think of these statements and all. So you need to concentrate this statement first. What is the size? Next, what they asked here. Next, what details they needed. So they needed the score greater than 50. So the answer is the array of 50 numbers. So that is the thing. One second. One second, ma. So you need to understand this only. Okay. So only the array of 50 numbers you can able to fetch for starting from 51 to 100. So like this only they will confuse you. Okay. So 51 500 integers. So 500 integers. It is not possible to store the 500 integer in the single array of 0 to 100. That is a 100 value. So only first 100 integers only we can able to store. So that is a major thing you need to concentrate. So next one is stack. So stack and queue. Based on the stack and queue, I seen lot of questions. Lot of questions I seen in stack and queue. I seen only a few questions in arrays. So in that few questions, I skipped some simple questions and come back to this twisted questions and all. So only I given only two examples in that. But in Stag and Queue, there are a lot of questions they asked, concept wise, and in Stag applications as well as in Queue application, lot of questions I asked. They asked in Git. So what you need to understand in stag is what is the principle of stag and what is the principle of queue. You need to understand. You need to know this difference between these two. What is the principle of insertion and deletion of stag and what is the principle insertion and deletion of the queue. You need to know this difference first one because according to the question I'm saying. Second one is what are the applications of stag that you need to know because what are the application you need to know. That is a second thing. So we will discuss all those things one by one. So what is a stack? So stack is a it is a one way of insertion and deletion. The simple thing is one way of insertion and deletion. In one way only we can able to insert as well as in one way only we can able to delete. That is the best thing. So the a best example of stack everyone will say placing the coin one after another, or placing the CD, or placing any book one after another. This is not a well and good examples. That is fine. Okay, that is understanding purpose. That is okay. But the best example is what I say is undo and redo. You can able to see this in using MS Office, Word, PowerPoint, Excel, etc., etc. Can able to use this undo. So in undo and redo, you can able to view the exact stack operations. Okay, so that is the best thing. So the stack is an order of list in the collection of list in which all the insertion and deletion are made in the one end. So in one end only we can able to insert as well as we can able to delete. That end name called the top. So with help of the top position only we can able to insert and with help of the top position only we can able to delete. Stacks are sometimes are referred as last in first out. So what is the last in first out is which element inserted last, that element we can able to delete first. That is the principle. So we need to know this principle first, last in first out. If you're coming for the queue, it is first in first out. Which element inserted first, that element we are going to delete first. Here, what is the element inserted last, that element going to delete first. So that is the difference between this tag and queue. So stack are sometimes referred as LIFO, that is last in first out. So how to implement the stack? So we have two implementation. One is array, that is a static memory. Another one is linked list, that is dynamic memory. These are all the two ways of implementation of the stack. So why you are going for linked list? That is a dynamic memory allocation. Is the reason behind is the static. The size is fixed one and insertion and deletion are very complex every time because we need to shift the elements. A lot of process we need to do. So for that purpose, we are going for the dynamic memory allocation linked list concept. Whenever we need memory, we can able to create the memory and we can able to store the data. Or if you don't want that particular elements data, we can able to delete the data and we can able to reuse the memory. That is a major advantage of dynamic memory allocations, linked list concept. This is some useful terminologies which are associated with the stack. So in stack, the insertion and deletion are called as a push and pop. The push is called insert and pop is called delete. Remove the element from the stack. And top is for the position of the stack. And LIFO refers to the last in, first out, the behavior of the stack. This is some useful terminologies of the stack. Next, what are the ADT operations? So create, insert, delete, display. This is a common ADT operation for all types of data structures. The linked list, queue, stack, trees, binary search tree, and AVL tree, or whatever maybe. These are all the common ADT operations. But there is some specific ADT which are need to be included for stack. So this is some specific ADTs. So stack full and stack empty. So before inserting any elements, we need to check the stack full condition. And before deleting the element, we need to check the stack empty condition. These are the two compulsory condition we need to check. For display also, we need to check the stack empty. Because if it is empty means we not to display anything. So before deleting, we need to check whether stack is empty or not. If it is not empty only, we need to delete any elements. So that is the important thing. If stack is full means we can't able to insert any elements. So before inserting, we need to check stack full or not. And we have two types of implementations. One is array and another one is linked list, one static and dynamic. For static alone, we need to check these two conditions, stack full and stack empty. And for dynamic, we know we have to check the stack full. Because it is a dynamic memory allocation, no need to check stack full. We can able to create n number of we can able to insert n number of datas. Okay, n number of records we can able to insert. So no need to check this stack full for dynamic memory allocation. So the stack empty alone we need to check for dynamic memory allocation. No need to check this. So this is a basic ADT operations. And this is how to declare the stack has defined size pi. This is a macro definition. And this is a in stack size and top equal to -1. So what is the meaning for this top equal to -1? Let me see next. Top equal to -1. If stack is empty, okay, stack is empty, then top equal to -1. If stack is empty, the top equal to -1. Okay. So they will ask and get what is if stack is empty, what is the top position? So top position is -1 only. Okay, if stack is empty, the top position is -1. If you're coming for the queue, if queue is empty, the front and rear position are in -1 for static memory allocation. I'm saying about this and all for the static memory allocation, not for dynamic. Next, insert. I will give some two examples for insert and delete, and directly we go for the applications and examples for the stacks. So insert, already as said, we need to check the condition whether the stack is full or not. So they will ask the condition for stack full. So you need to know what is the structure program, that is the function for stack full. So in stack full, they use various names for stack full. This is a function name, that is a user defined one. So user can able to give according to willing. So I am giving st full, that is a stack full. Then if st dot top, or don't want this st dot top, instead of that I'm giving top, because I'm going to use any structure concept here. So this is st means st dot means a structure concept. I didn't use any structure concept. So size -1, size -1. If condition true means this will return 1. And else condition false means this will return 0. So let me compare this stack full condition with this void push. So if top greater than or equal to size minus one, if the condition true is, this will return one. This return one means print of stack is full. If this condition fails means this will return zero. So I can able to go for the insertions. I can able to go for the insertion. This is the return zero. Condition false means I can go for the insertion. Okay, so this is a stack full condition. They will ask like that, what is the stack full condition? So out of this four answers, find out any one. So this is a condition, if top greater than or equal to size minus one, return one, else return zero. This is a stack full condition. If it is a stack empty, your thing is if top equal to minus one, because already a stack said if stack is empty, the top portion is minus one. If top equal to minus one, then stack is empty. So with this, we'll directly go for the insertions. I'm going to insert 10. Okay. So before that, where is the top position? The top position is minus one. So minus one greater than or equal to size minus one. Your size is 5. 5 minus 1 is 4. So condition is false. So directly come to the else part. Enter the element scan of percentage the item. In item, I'm going to get the element 10. So I'm getting the value 10. And next, I'm incrementing the top plus plus. Top plus plus is the top position is minus one. Minus one plus plus. What is the meaning of plus plus is top equal to top plus one. Top equal to top plus one. This is a meaning for this plus plus. Top equal to top plus one. So minus one plus one, that is equal to zero. Okay. So in stack of zero, I'm going to place the item 10. Item value is 10. In stack of 0, I'm going to place the item value 10. This is the meaning for that. So 10 and top position is incremented to 0. Next, I'm inserting a next element. Next example is I'm going to insert next element is 20. Now the top position is 0. 0 greater than or equal to size minus 1, that is 4. Condition is false. Directly come to the else part. Enter the element. And item I'm going to get 20. And I'm incrementing the top position plus plus. So the top position is 0. 0 plus 1 is 1. 0 plus 1 is 1. So 1 now. So in stack of 1, I'm placing the item 20. In stack of 1, I'm placing the item 20. Top position is incremented to 1. In stack of 1, it is 20. So what is this top position is? What is the current position of the stack? So the current position is 1. So with the help of this only, we can able to store and retrieve we can able to retrieve as well as we can able to delete the element from the stack. So this top position is a key one. Okay. So this is some example of insertion of insertion the element in the stack. Next one is delete. So already I said if the stack is empty, then the top position is minus 1. Yeah. If stack is empty, then top position is equal to minus 1. Because if it is minus 1, then stack is empty. Already I shown that example. So before deleting the element, we need to know whether the stack is empty or not. That is our thing. Okay. So I'm going to delete first. And here one more thing. Consider this example. Here we can't able to delete the element 30 or 20 directly. That is a major thing in stack. If you want to delete 20 or 30 means you need to delete 40 first, then come back to 30, you need to delete, again you need to delete 20. This is the order. So simply you can't able to delete the 20 because according to the stack concept, last in first out. Which element inserted first? Sorry, which element inserted last? That element we can able to delete first. So that is our principle. So they will choose like you. So delete the element 10. Simply they will ask like that. So it is possible in stack or not? Yeah, they will ask a question like that. So it is not possible. So first we need to delete the 40, then you need to delete 30, then you need to delete 20. After that only we can able to delete 10. So total number of deletion is 4. After after 3 or 4 deletions only we can able to get the value of 10. So that is a major thing in stack. So mostly all the students will simply delete 30 means they yes we can able to delete 30. They will simply say like that. It is not possible. So first you need to delete 40 only. You can able to delete 30. That is our thing. Okay. Now we come back to this delete. So void pop if top equal to minus 1. So I'm according to this the top position is 5. So 5 equal to minus 1. Okay. 5 equal to minus 1. Condition is false. Directly come to the else part. Stack of top. Your top position is 5. So stack of 5. What is stack of 5? It is 50. So 50 I'm placing an item. Then top minus minus. Extra p is there. Okay. Top minus minus. So your top position is 5. Previously we are incrementing. Now we are decrementing. So meaning for this top equal to top minus 1. So top minus 1 is 5 minus 1 is 4. So just for user thing, we have printed the deleted element. Now the top position is 4 and element is deleted. Okay. Next, I'm going to delete the next element that is 40. Now the present top position is 4. 4 equal to minus 1. Condition false. Directly come to the else part. Top position is 4. What is tag of 4? Tag of 4 is 40. The 40 I'm placed in item. And I'm decrementing the top position. So 4 minus 1 is 3. That's it. So 2. Okay. This is how we can able to delete. So we can able to delete one after another only for in the stack. But in array we can able to delete the element 10, 20 randomly we can able to delete. But major thing is we need to shift the elements for the sequential order. But in stack we can able to delete one after another. Simply we can't able to delete the 10 directly. So first we need to delete all the elements from the stack only we can come back to the 10 and we need to delete. This is a major problem in stack. So keep concentrate for this stack last in first out principles. Then previously they will ask the question what I said. What we I seen some few one or two questions, but if you come back to the queue only, I can able to explain that stack and queue simultaneously. But the most of questions they ask in application of stack. So expression conversion, expression evaluation, passing, well form, balance, parenthesis, decimal to binary conversion, reversing of string, function calling, this and all the various application of string, application of stack. But the important application is function calling. Okay, the important thing is function calling because why I'm saying this is an important application is if you are shutting your system, it will check the stack first. Is, is it any application is opened or not? Don't think about the system application, the user-oriented application, whether it is any open or not, because it throws some errors if you try this. If suppose I'm going to shut down the system at the time, if some of the application are open means it throws some errors. You want to force to close this or not, it will ask like that. Because if stack is empty only, the system will get shut down easily or it get restarted. If stack is not empty, it throws a error. We need to force to close this or not, like that. It will ask error. After that only, this will work. So this is an important thing for your stack, the function calling. But we won't concentrate much more thing for function calling. Only we are concentrate for the first three applications: expression conversion, expression evaluation. But I didn't see any questions from this passing well form balance parenthesis. I've seen most of the questions from expression conversions and expression evaluation. And decimal to binary conversion, the reversing of string also, I didn't see any questions. Function calling also, still now I didn't see any questions. If I seen, I will give some example for that also. Next, expression conversion. So before going to expression conversion, what is the expression? So expression is a string of operands and operators. A string of operands and operators. So basically, there are two operands. So basically, there are two types of operators. One is unary operator, another one is binary operator. Unary means plus plus, that is top plus plus and top minus minus, and binary means it is a regular expression. So we have one operand that is a plus b or a minus b or a hashtag b or a slash b is a binary. So bi means two. So your two indicates your operands, not your operator. Unary means a single operand. Okay. And we have some types of expressions: infix expression, prefix expression, and postfix expressions. This and all the major three types of expressions we have. This infix is a regular expressions because here we are using the open and close parentheses. With that, we have a regular operands in between. We have the operators and all. This is a regular expression. Prefix and postfix are pre means in advance, post means after. Pre means in advance. So the operator will come before. In advance, the operator we have. Post means at the last, at the end, we have the operators. So this is an example. You need to mark up this formula. You need to understand this formulas. This is an important formula. If you know this formula, it is very easy to find out some answers. So the formula for infixes operand 1, operator, and operand 2. An example is A plus B. So A is operand 1, plus is operator, and B is operand 2. And postfix is last at the end. Post means at the last. So operand 1, operand 2, operator, A, B plus. So A is operand 1, B is operand 2, and plus is the operator. And prefixes in advance. You have the operator. So operator, operand 1, operand 2. So plus is operator, operand 1 is A, and operand 2 is B. So this is an example for infix, postfix, and prefix. So try to mark up these formulas. If you mark up this, or if you conceptually, if you know this means there is well and good. And this is the next important thing: operator priorities. So the first highest operator is dollar, the upper arrow mark, and the power. This is the highest operators, that is three. And next highest operator is hashtag and slash. And next highest operator is plus and minus. This is the order we need to solve. So in that also, this dollar, the upper arrow mark, and power, we have some orders for this, the priority orders. So in the expressions, if dollar, uh, if we have the expressions like this, so A, B, C, D. So first we need to solve this dollar. Next we need to solve this upper armor. Next we need to solve this power. This is the order you need to solve. The highest, the operator, the given highest priority is the dollar, upper mark, and power. But according to that one, first we need to solve the dollar. Next we need to solve the upper mark. Next we need to solve the power. If we come back this hashtag and slash, if the equations like this, A plus B hashtag C minus D slash E. If we have the equations like the expressions like this means, first we need to solve this B hashtag C. Next we need to solve this D slash E. Next we need to solve this A and this converted answer. And finally need to solve this minus. So in the Facebook or in the WhatsApp, you have seen some example like this. 2 plus 5 into 6 minus 3. So 99 percentage of peoples will fail in that. You will see the example like this. The reason behind is, according to the operator priority, first we need to solve this one. 5 into 630. After we need to give the preference to plus. Plus and minus are the same priority, but if plus and minus are in the expression, we need to solve the plus first and need to come back to the minus. So 2 plus minus 3. So 2 plus 30 is 32. Then 32 minus 3 is 29. This is the answer. Because they don't know about the operator priorities. So 99 percentage of peoples will fail in that. So this is a major problem. So if suppose if we solve simply, what happens? 5 plus 7. 7 into 6 minus 3. Then 7 into 6, 42 minus 3. So that is 39. So that is a problem. Okay, so we need to know the priorities of each and every operator. So that is a major thing. So this is a general algorithm for the infix to postfix expression. Read the expression from left to right. Um, so before going to this, directly we come back to the example. After we'll go back here. So this is an expression. So keep in mind we have three types of expressions we have. So infix, prefix, and postfix. With the help of the stack, we can able to convert only infix to postfix alone. It's not possible to convert infix to prefix or postfix to prefix or postfix to infix. This is not possible or any format. So only format we can able to convert is infix to postfix expression using stack. Using stack, we can able to convert only infix to postfix. That is the important thing. Okay. So this is a expression we need to convert with the help of the stack. Okay. So before going to this, I need to say some, according to the algorithm, I need to say. So for that, we are going to use a table in that we have input and followed by a stack and followed by a postfix. So if the input symbol read is an open parenthesis or the operator means we need to place in the stack. If the input symbol read is an open parenthesis or operator, we need to place in the stack. If the input symbol read is an operand, we need to place in the postfix. If the closed parenthesis is read means we need to pop all the operator from the stack until the respective open parenthesis. Until the respective open parenthesis, we need to pop all operator from the stack and we need to place in the postfix. Okay, and we need to delete the open parenthesis from the stack. So this is a concept we are going to do. the input stack and postfix. So for the first input symbol is open parenthesis. So already I said we need to place in the stack. Okay. So next input symbol is open parenthesis. Again, we need to place in the stack. So next input symbol read as an operand. We need to place in the postfix. Next input symbol read is an operator. So stack can able to hold the operators and open parentheses alone. So we need to place that operator in the stack. So next input symbol is minus. So next input symbol is open parenthesis. So we need to place in the stack. So next input symbol read is an operand. Operand we need to place in the postfix. So next input symbol read is an operator. So we need to place in the stack. So next input symbol read is an operand. We need to place in the postfix. So next input symbol read is an close parenthesis. So what I said, if close parenthesis is read means we need to pop all the operators from the stack and we need to place in the postfix until the respective open parenthesis. So what is the respective open parenthesis for this close parenthesis? This one. So up to this open parenthesis, we need to pop all operator from the stack and we need to place in the postfix and we need to delete this. So the plus will come here and we need to delete this open parenthesis. Okay. So next input symbol read is an operator. So here the important condition we need to satisfy. So I will say some simple example for this. Lower priority, higher priority, then higher priority, lower priority. So this is a stack. Okay. So here, if we have the condition like this, below lower priority, above higher priority, this condition is true. If we have the condition like this, below higher priority, above lower priority, this condition is false. Okay. Need to keep this concept alone in our mind. This is for the conversion of stack using infix to postfix using a stack. If we have the below lower priority, above higher priority means the condition is true. If it is below higher priority and above lower priority means condition is false. So what we want to do for this, that we see later. Okay. So according to this, this does not look like a stack format, but actually this is meaning is open parenthesis minus hashtag. This is look like this. This is a meaning for this. Okay. Open parenthesis minus hashtag. So we have two operators in the stack. If we have a continuous two operators in the stack, we need to check these two conditions. Which condition is true or which condition is false? We need to check. So this condition is true. No need to do anything. If condition false alone means we need to do anything. But this condition is true. We don't need to do anything. Simply leave as it is. Okay. Simply leave as it is. So if lower priority below and higher priority above means the condition is true, leave as it is. Then next input symbol read is an operand. So if operand is read means we need to place in the postfix. Next input symbol read is an close parenthesis. If close parenthesis read means we need to find out the respective open parenthesis. So this close parenthesis respective open parenthesis, this one. Up to that, we need to pop all operator from the stack and we need to place in the postfix. And we need to delete this open parenthesis. Okay. So we need to delete this open parenthesis. Up to that, we need to pop all operator from the stack and we need to place in the postfix. So first, if we pop, we will get hashtag and followed by minus. Okay, so we have popped and delete this open parenthesis. So we have only a single open parenthesis here. Next input symbol is dollar. So dollar is an operator we need to place in the stack. Next input symbol read is an open parenthesis we need to place in the stack. Next input symbol read is an operand we need to place in the postfix. Next input symbol read is an operator we need to place in the stack. And you have another confusions. So here one operator, here one operator. If two operators are in the stack, we need to whether check the condition lower operator, higher operator, or higher operator, lower operator. This condition. Yes, every time we need to check. But the thing is, in between we have one open parenthesis. Okay, in between we have one open parenthesis. So it is a sub expressions. If you see, this is the first sub expression, this is another sub expression, this is another sub expression, and this is a final expression. This is a whole is a final expression. So in the expression, we have a lot of sub expressions are there. So if you have the open parentheses in between the two operators, means no need to worry for this checking these conditions and all. Okay, no need to worry. No need to check these conditions. Suppose if we have like this, you need to check the condition. That is the important thing. Okay, that is the important thing. One second. Okay, so no need to worry this and all. Uh, Simply we have the open parentheses between any two operators. Don't need to worry to check the conditions and all. So next input symbol read is an operand we need to place in the postfix. Next input symbol read is an close parenthesis. So if close parenthesis read means we need to check with the respective open parenthesis. So this is a respective open parenthesis. Up to that, we need to pop the operator and place in the postfix. So this is your respective open parenthesis. Up to that, we need to pop and place in the postfix, and we need to delete the open parenthesis. And the last input symbol is an open parenthesis. We need to pop and place in the postfix. This is your answer. So this is the one way, and it takes about nearly 3 to 4 minutes or 5 minutes. Hardly it takes some 5 to 6 minutes to solve the given expression. If the expression seems to be like this, if it is a bigger expression, means surely it takes some 6 to 7 minutes also. So this is not a good one. To avoid this, we are going another method of solving. The let me discuss. So what we want to do is we need to split the expressions. So already I said the formula operand one operator operand two. This is the formula for infix, and formula for postfix is operand one, operand two, and operator. So with the help of this formula, we will divide the given expression into various sub expressions. So this is a sub expression one. We need to solve this, and we need to solve the next sub expression this one, and we need to solve the next sub expression. Because why I'm solving this is enclosed with the parentheses, and in between we have two operator. This is first operator, this is second operator. So while coming for the priority, this have the highest priority. So first we are solving this one. Next we need to solve this a minus, and finally we need to solve the entire thing. This is very simple, and it takes only 1 minute or less than hardly less than 1 minute. So how to solve this? So you know the formula for infix, operand 1, operator, operand 2. You know the formula for postfix, operand 1, operand 2, operator. So this is operand 1, this is operand 2, this is operator. This is operand 2. So this operand 1, operator, operand 2 is a converter to operand 1, operand 2, operator. That is a postfix. So BC plus. So BC plus. So this is converted into BC plus because we need to solve this expression first. Next, we need to solve this expression EF plus EF plus sorry E plus F. So if E plus F are converted to postfix means operand 1 is E, operand 2 is F, and F is plus is the operator. So EF plus. Okay, we get this EF plus. Next. So if you look at this, these are enclosed with the parentheses. So in between we have two operators, minus and hashtag. So only I said, first we need to solve this one. So first we need to solve this one. Okay, that is this one. So you have a confusion. How to solve this one? Because this is a converted one. This BC plus is a converted one. Okay, if a B plus C is a expression, BC plus is a converted one. You have got an output. Okay, so this is the output and this is the input for the next expression. So this BC plus is operand 1, hashtag is the operator, and D is a operand 2. So BC plus D hashtag will come. BC plus D hashtag will come. And next we need to solve this expression. So here A is operand 1, minus is operator, and BC plus D hashtag. It is a converted one. So we need to use this as a operand 2. So after we solve ABC plus D hashtag minus will come. Okay, now this is the expression operand 1, this is operand 2, and this is the operator. So if we solve this, AB plus ABC plus D hashtag minus EF plus dollar. So this is the answer we solved using a formula method and checked with the answer with the stack method. AB plus D hashtag minus EF plus dollar. Both will give the same answers. But according to the time, the stack method takes a large amount of time to solve, but the formula method will get a less amount of time. This is the difference. So directly we go for some examples for this. Yes, this is the first example of they ask in Git. The best data structure to check whether the arithmetic expressions have balanced parentheses. Okay, so balanced parentheses or arithmetic expressions comes under the tag only. Okay, tag only. The tag applications are expression conversion, expression evaluation, passing well-formed balanced parentheses, decimal to binary, reversing of string, then function calling. These are all the examples. So tag is your answer. B. Next, this we didn't completed. Okay. Yes, this is the next one. Assume that operator plus minus hashtag are left associative and power is a right associative. The order of precedence from highest to lowest and the postfix expression corresponding to infix are. Okay. First, what you want to do is you need to solve this first. Okay, you need to solve this first because what they said is assume that the operator plus minus hashtag up to this. Okay, first we need to solve this. Plus minus are less associative and power is a right associative. So you need to solve this secondly. Okay, and what is a postfix? So assume this AB plus hashtag first. ABC hashtag C. This is the first. And D power E power F. This is the second. Okay, right associative. So if you solve this, the plus and hashtag are in the given expression. So according to the priority, we need to solve this hashtag first. So BC hashtag, then A plus. After solve this, we will get ABC hashtag plus. Okay. So with this answer, with the first part of answer, you can able to find the answers here. So ABC hashtag plus. So ABC hashtag plus we have in two, option A and B. Okay, option A and B. So with the fraction of 30 seconds, you completed out of 4, you find out some 50% of answer. Next, you need to go for this. So D power E power F, both are the same priorities of operator. So no issues, and it is right associative. Okay, right associative means you need to solve first this right side first. So right associative means you need to solve E F power, then D power. So instead of that, if you solve the left to right means what happens? E D power and power F. This will come like this. After if you solve DE power F power. So you'll have some different answer. So they're given right associative. So you need to solve the right side first. E power F. Then this is operand, this is operand, this is operator. So D E F power. Okay. And finally minus. So the minus will come at the end. So this is the answer. So this is how we need to solve. So if you use the stack method here, hardly it takes some 5 minutes for to solve this methods. So the simple thing is understand the question. So the assume that the operator plus minus are left associative. So I am splitting this expressions and the power is right associative. The order of precedence from highest to lowest. So leave this highest and lowest and all. So split the expressions. Split the expressions into this is the first expressions we need to solve. This is the second expression we need to solve and leave the minus. So if you solve this first expression, you can able to find out the 50% of answers. Out of this 4, you can able to find out the 50% of answers because these two will get the answers here. And you need to solve the remaining. So this is what you need to do. And the next one is this we'll see in the later. And the best data structure already we've seen this tag, the repeated question. And yeah, this is the next. The stack operation. This is how they will ask. If the sequence of operation push one, push two, pop, push one, push two, pop, 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 push two, pop, or perform on the stack, what are the sequence of pop out values? So a stack here, okay. They didn't mean any size and all, just have some size of the stack. Push one. So push is inserted. Push is for insert. Pop is for delete. Push one. And next one is push two. Next they're giving pop. They didn't mean any values. In pop they didn't mean any values. For push they given some values, but pop they didn't mean anything because according to the stack last in first out, which is inserted last, that is going to delete first. So that is the principle. So they didn't mean any values here. So the two. The pop means I need to delete the value 2. So 2 is deleted. Next, they're giving 1, push 1. This one, push is 1 inserted. Next, they are giving push 2. 2 is inserted. Next, they are giving pop. So pop means I need to pop the element, this 2. I need to delete the 2. So somewhat you get the answers. Initially, somewhat you get the answers. 2, 2. So 2, 2 means this 2 alone. 50% of answers from the 4 you get it. Next, pop pop. So first one pop is completed, next pop. So if pop means I need to delete the last inserted. So it is 1. Next another pop. So it is 1. Another 1. So the 100% answer you got it. Reason is out of this A and B, 2211 is similar you are getting here. Next we need to check out this also. Push 2. So push 2 and pop. So pop is 2. So the answer A is correct. Okay. The answer A is correct. So sometimes they will ask a question like this also. Next, another thing. Consider the following operations perform on the stack size 5. So they given the size of the stack. Previously they didn't given any size, but presently they're giving a size. So you need to assume the size should be 5, not more than or not less than. So 0, 1, 2, 3, 4. The size should be 5. Push A. I push A. Next, they're given pop. So pop. So they didn't ask any of popping arrangement of data. Simply, which of the following statement is correct? So no need to record the pop element. So no need to worry about that. Next, pop push B. B is inserted. Next, push C. C is inserted. Next, pop. So pop is you need to delete B alone. C alone. No need to delete B. Next, push D. Next, pop pop. Next pop off means we need to perform two pop operation. First we need to delete D. Next we need to delete B. Next push E. So stack contain one element. So which of the following or statement is correct? Underflow is occurred. So underflow is I forgot to say overflow and underflow. Underflow is stack empty condition is underflow and overflow is a stack full. Okay. The stack is full and we are inserting more than elements means the overflow occurs underflow. If a stack is empty, the underflow is occur. So underflow surely won't occur because we are not deleting in because after push there is no pop operation is carried forward. So no need of this answer. Stack operations are performed smoothly. Yes, stack operations are performed smoothly. Yes, it is correct. One answer is correct. Overflow occurs. So still we didn't face any overflow conditions. So this condition is also false. None of above. No, it is not none of above because the stack operations are performed smoothly. We pushed A and popped A and pushed B and pushed C and popped C and pushed D and we performed two pop operation. So we popped D and B and after we are pushing E. So none of the things are the stack operation are performed smoothly. There is no issue of overflow or any underflow operations. So stack operation performed smoothly. So answer B is right. Okay, this is how they will ask the question in the gate. And what is a respective infix postfix expression for this? So A, so you need to use the formula method. No need to go for the stack method. So if you use the stack method, the time taken is very large. Hardly takes some 3 to 4 minutes also. Okay, so this is the expression. So first we need to divide this expression. Which expression we need to solve? So first we need to solve this one. This is the first sub expression. This is the second sub expression. This is a third. After that, we have slash and plus. So slash is a higher operator. We need to solve this one. And finally, we need to go for this plus. So let me solve this. So a plus instead of that also you can able to simultaneously you can able to solve. So first solve this two. E minus f and b power d. Simultaneously, you can able to solve this too. So bd power here slash e minus e F minus plus G. Next, you solve this expression. So A, B, D power plus, then you have a slash E, F minus plus G. Then, so after performing this, after converting this, you can able to find some answers here. A, B power, this is one answer, and this is another answer. These two are possibles. First two possibles are there. These two won't come. Okay. Next, you need to solve this one. So the plus and minus, slash and minus, sorry, slash and plus. The slash is a higher operator. So we need to solve this one. So A B D power plus E F minus slash plus G. So after that, mm, you can able to verify the answers here. So you have this one, you have this one. Out of these two, so you can verify these answers. No need to solve the final answers and all. So AB plus ABD power plus EF minus slash. So this won't come. Minus power, this won't come. So the answer is ABD power plus EF minus slash. This is the answer. After solving this, the G will come here. Okay, the G will come here. So this is your answer. This is how also you can able to predict the answers. So this and all the some examples what I seen in the stack. Okay, this and all the some examples I see in the stack. So next one is expression evaluation that we need to discuss something. The algorithm. Yes, this is algorithm. So read the expression from left to right. So you need to read the expression from left to right. If the input symbol read is an open parenthesis, push onto the stack that we did. If the input symbol read is an operator, then placed in the postfix. That also we did. If the input symbol read is an operator, if operator is read means we have a condition. So already I said lower priority, higher priority, then higher priority, lower priority. If we have the condition like this means it is true and it is false. Check if the precedence of the operator which is in the stack has a greater precedence than the precedence of the operator read. If so, remove the symbol from the stack and place in the postfix expression. Repeat step 4a till the operator of the stack has a greater precedence than the operator being read. So this is what they're saying. Otherwise, push the operator being read onto the stack. So this they're saying. If the input symbol read is a closed parenthesis, then pop all the operator from the stack, place them in the postfix till the open parenthesis is not popped. Then the open parenthesis not placed in the postfix. You need to pop and delete this. This also we did. Finally, print the postfix expression. So this is the algorithm for conversion of infix to postfix. So this is the algorithm and don't prefer for this method because hardly gives some 5 minutes to solve this problem. Preferably go to this method. Preferably go to this method, formula method. So this will give some hardly less than 1 minute or less than 2 minutes. Okay, less than 1 or 2 minutes. So this is the thing. So the questions are around 5 to 5 questions they ask in gate. I also explained that one. So this is an open forum. If you have any doubts, you can ask. Subhashri ma'am, shall we wind up the class? So I will go open forum for asking your questions. Any doubts if you have.
Okay, sir. Students, if you have any questions, you can ask now. You can post the questions in chat box or you can unmute your mic and ask.